DisruptOps helps you find and fix cloud security issues fast. Getting bombarded with irrelevant alerts is frustrating. DisruptOps gives security and DevOps teams prioritized findings and routes relevant alerts to Slack or Microsoft Teams with automated response options that save you time. Finally, security is inside your workflow instead of in your way. Listeners can access the full platform free for 30 days by visiting securityweekly.com/DisruptOps. Are you looking for a solution to protect your web apps against the most business-critical security vulnerabilities? Unleash the power of automated ethical hacker knowledge with Detectify for continuous coverage and relevant security vulnerability findings. Upgrade your web app security with speed and scale and start a 2-week free trial at securityweekly.com/Detectify. Go hack yourself. Whether you need to manage bots, protect cloud applications at runtime, stop formjacking attacks, or secure your web applications and APIs, only Imperva offers a unified solution to protect from edge to application and data in one tool. Imperva helps you achieve more, save money, and become more efficient with fewer security vendors needed. Start a free trial today to easily protect your apps and website with Imperva. Learn more at securityweekly.com/Imperva.
Welcome back to Application Security Weekly. I'm your host, Mike Shima, joined by John Kinsella. Security Weekly Unlocked will be held in person this December 5th through 7th at the Hilton Lake Buena Vista. We are excited to announce our first round of speakers. It's a long list, so give me a second to catch a breath. We have Leslie Carhart, Dave Kennedy, Alyssa Miller, O'Shea Bowens, Marina Savada, Patrick Coble, Chris Ang, Eric Escobar, Nick Leghorn, Michael Schlatt, Kevin Johnson, and Justin Kohler. Visit securityweekly.com/unlocked to register and check out more of our exciting lineup. You can also join us on August 26th at 11 a.m. Eastern to learn how to implement cloud security that actually works. Visit securityweekly.com/webcasts to register now. And if you missed any of our previously recorded webcasts or technical trainings, they are available for your viewing pleasure at securityweekly.com/on-demand. And this brings us to our news segment. Thank you for continuing to join us. And the news segment, John, you're carrying the flag again for hardware. You've got some cool hardware security articles this week.
I do. Just screw them. Thank you. Anything else I can talk about?
That was, yeah, exactly. There's a great
there was two.
Go ahead.
That actually could be. I'll let you work on that one. So there's two articles in here. The hardware stuff's interesting, and it's funny. Man, I got to find time. So the first one we got here is an article talking about doing voltage glitching in AMD CPUs. So I think historically when we've talked about voltage glitching, it's a relatively new thing we've seen over the last, 10 months or so. It's sort of, I think, been on my radar. But it's usually been talked about with small microcontrollers. I think at the end of the day, this is sort of a scary area to play in, right? If this was being done on some of AMD's bigger CPUs, I don't know if I model in here, but it's something that has SGX, which isn't a small CPU. So this is like a desktop class or laptop class CPU. They're not cheap. So you're going to start thinking about doing voltage glitching, like we had Maggie on a few weeks ago talking about how do we get into hardware hacking. You're not going to start on a desktop class CPU, right? That's not a cheap thing to start, because if you glitch that bad boy a little bit too much, So it's interesting to see as the researchers started with the cheaper CPUs, they're now actually having confidence to start working on this with the higher end stuff. So this was a good example of that, and it's a really interesting area. I'd love to play with the space if and when I get some time. But that was the first article. I don't know if you had any thoughts about that, Mike, or see voltage glitching in your future.
I see. I'm definitely going to do it with some alligator clips and a voltmeter. So I'm going to do it with the. I'm going to be very heavily on the crawl side of the crawl, walk, run. So those CPUs are safe for me for quite a while.
Nice. You'll just have like a what Strongbad called it. You'll have a light switch rave with your CPU. And then, so the next article for our Strongbad fans out there, next article was talking about, what are the benefits around RISC-V CPU architecture? This is the open source architecture for RISC, the open source RISC architecture. Man, they've been working on it for a while. I think it's been at least 5 years, but it's gained popularity over the last year or two. You can start buying some RISC-V CPUs out there, microcontrollers. and used them in that sort of Arduino class of stuff. But the nice thing about this open architecture it's an open source CPU architecture. Beside that, you can model it on FPGAs and other sort of you model it in software, if I can talk. But you're also able to, once you've got that model in there, you can start doing some pretty neat what ifs without having to use either a weaker, smaller architecture, which is designed for academia, or you're definitely not going to get the architecture behind Intel CPUs, right? So how does someone who wants to play in a microcontroller space, how do they get that? RISC-V lets you do that. And in this particular case, there's some researchers looking at how would we, we've got this upcoming, everyone's worried about one of these days we're going to get quantum computers common enough that we're going to be able to start cracking passwords and crypto's going to fall apart and all that whole doomsday scenario. Some of the academics and researchers will figure out, well, what can we do about that? Is there something we can do in a CPU to make those type of attacks from a quantum computer to be more difficult? And in this case, what they did is they added 29 different instructions in there, which would help, between both focusing around crypto, but also making it more difficult to block that. So it's neat to see what you're able to do with an open source CPU to be able to put some of that stuff in there. And this is sort of a neat read for people to want to think about what do they do in that space.
Yeah, it's really, really neat. I think RISC-V came across my radar 2 or 3 years ago, listening to a hardware security conference where some academics were talking about just a lot of work they've been doing with those chips. And it's really neat to see that I think, as you mentioned, that I really want to emphasize that open source design aspect of it really makes it a great sandbox that looks like hopefully becomes much more than just academic, and we get some actual, some practical deployments of chips with built-in crypto, built-in protections from different classes of types of attacks too, not even just quantum cryptography, but memory safety issues or other types of encryption, timing, those types of issues. So neat to watch, and I'm definitely going to leave that on your radar because I think you're definitely more geared and tuned in than my brain can handle. Because my brain, for example, can handle the software side of things. And this is where I picked up 2 articles going into one about Steam that was not a misuse of a hash function, but an input into a hash function. And this is a case where a researcher found a really neat way to bypass how the strings were being concatenated together of a name-value pairs of URL parameters, essentially, which these URL parameters were concatenated and hashed so that Steam could say, well, this is what we think the amount of a transaction was, and we want to hand it over to our payment provider and say, yep, here's, authorized $20 payments, or this is, we need a $20 payment here. What the researcher found is that they could concatenate the strings using some clever renaming of names and values. So amount equals 2,000 or $20, for example, becomes amount 2 as the name of the variable equals 000 as the value, and then use some nifty creative uses of email addresses to stick in their amount equals 1, for example, just $1. And that's the long way of saying that what happened was that the hash function itself didn't really matter here because it could have been secure, it could have been insecure, it could have been an HMAC. Well, it couldn't have been an HMAC, but what happened in this case is that the developers missed delimiters, and the delimiters are necessary when doing this type of string concatenation so that you can actually keep that semantic meaning that this is a field name and this is a field value. And it's one of those things that I had actually come across when I was trying to building a web scanner, uniquifying URLs based on parameter name and value, and getting some weird collisions when names and values put together in a long string of letters became very confusing. So it was a really neat thing that it spoke to me, John. So that's why I had to throw this particular HackerOne bug bounty report in there.
Well, if it speaks to you, then I mean that's reason enough. What's interesting about this bug bounty stuff? I was interviewing a candidate to hire as an engineer, software engineer, earlier today. My day started early, and it wasn't on his resume. But as we're talking, the dude starts saying, I was asking, how do you, what's your thoughts on security? What's your experience, that type of thing? It's like, yeah, I've done a few HackerOne capture the flags, and it's interesting. It's really starting to spread out the number of, because it's not something I would have expected. I didn't sort of sense that from this resume. I usually don't hire. I'm not looking to hire a developer who has security experience. That's just a plus, right? But I didn't see anything on his resume that gave me a hint of that. But I think I'm going to start seeing more of that, where people want to get experience on the side of the fence, that they're going out and using that as a platform to learn in a fun way, I think. So I think that's sort of cool.
It is cool, and that's a great setup for the other article that I pulled in from, I think this was from Bishop Fox. They found some vulnerabilities in some gym management web application, and it's just a classic image on error. XSS that they found, and a couple other like IDOR, a couple other vulnerabilities. But I think that ties back to what you were saying, is that you don't have to be super knowledgeable about security, because sadly there are some classic old school, if you will, vulnerabilities out there to be found if you just want to start looking. So it is a great way to use bug bounty programs to learn, educate, and get a sense of security, or just at least exercise that security-minded thinking. But one of the other things that stood out to me from this article, and I was like, made me scratch my head, as a bit more of a record scratch and say, hold on, we need to dig into this a bit more, is that there was an API endpoint that was returning a user's hashed password. Now, it was a hashed password. It looked like it might have been a bcrypt hash or something like that. So sure, fine, you're using a nice hash function, but why would you be exposing this anyway? So I was really curious, fundamentally, what was that design discussion amongst the dev team? Did they involve the security team to say, we need an endpoint that returns a hashed password? So I'm scratching my head here. And John, I don't know if you have any guesses or insight about how strange things like that might happen.
Well, we've spent a good amount of time talking about authentication tokens and JWT and things like that. And, that's just a lot of extra compute cycles. So maybe just instead of computing that token, you just return a hash, and wherever you got the hash, that's your valid to get in, right? I don't know. This is it's going to be interesting to see. So this particular part of the world, software-wise, right? It's someone who's written, this is not enterprise software. It's software to manage a gym. And the reason I'm going down this path, a gym is usually a SME, small, medium-sized enterprise or business. Mm-hmm. They're not going to have a ton of money either for security or for the software. So they're going to be looking at, a SaaS platform that is tailored to their industry. We're seeing this. I think Wix, the website creator, has a version for restaurants that I see a lot. So there's a bunch of examples like this. But those tools are usually, they've been designed by someone else who probably was a gym owner in the past that said, hey, I wish I could make this easier for myself and others. I got an idea. They hired some kid in high school, and maybe it's a team. I'm not trying to insult anybody if they might be great developers. But usually it's going to be not a professionally built product. If someone had an idea, they turned it into a business and off they went. Point I'm trying to get to is, in the future, that's just sort of the space where the no-code folks are aiming towards. How can they help them out? Be interested to see if that improves security around this type of thing, or if this is an area where AppSec is going to continue to be needed. It's a utility which has got a great use. People really want it, really need it. Imagine trying to do gym memberships, gym. I'm thinking of gym reservations over the last year if your gym was open during COVID. So there's definitely a need for the software. Now it's just how do we make sure that it's the security gets to the people that aren't security experts.
Yeah, I think that's a great point, and encourage everyone, please come check out the show notes as well. We have our own commentary, and as well as all the list of articles we're covering. And one of the things I did, also add about this particular finding was that the researchers, I think it took them several months, 7 or 8 months overall, to have the conversation about with the developers to say, hey, here's a bug, we need you to respond, and you're butting up against just a disclosure policy. We want to talk about this. And to me, kind of reading between the lines there, it sort of felt like it was just a lower maturity of development organization, an organization that isn't used to dealing with vulnerabilities. They're not used opposed to running even a bug bounty program or finding out, like you're pointing out, John, like, oh, oops, there's some vulnerabilities. There's some AppSec that we need to address. Maybe we should go find a podcast and learn more about it. But yeah, I think that's just that underlying theme is how can AppSec be better about embracing these types of applications and helping them start off secure from the beginning. And
that's an interesting point there, real quick. I did that talk at the last KubeCon, our Cloud Native Security Day, around security nutrition labels and how can an open source project broadcast their level of security? We've got a security response page, we've got all these type of things. At what point are we going to be putting on there? We've got a bug bounty program, and that's treated as a recognized level of sophistication or maturity. That's sort of something interesting to noodle on a little bit.
Yeah, and I think that's I think speaking of the Open Source Security Foundation, which I was about to speak of here, I think that's a great tie-in. I believe they do actually have a maturity model. I think it's the OSF, or maybe it's the Linux Foundation, that's sort of the idea of here's your open source project, and you have, if I'm remembering off the top of my head, so listeners, please Google along with me or search along with me and see if I'm right. Something like you have dedicated identified owners that have GPG keys, for example, but then you also have a bug bounty program for your project. And you have, I think you're running linters or possibly other security tools for your open source project. So there is some efforts from, I think, the LXF along that direction where you're describing, John. And now we have also the Open Source Security Foundation that's pushing, I think, something similar in spirit to that nutrition label, in the sense of we have a new Allstar program that they're calling it for GitHub, that is continuous automated enforcement of policies. And the reason I think this ties into what you were saying is that these policies are actually quite actionable, in the sense of, do you have this or do you not have this? And with the implication being that you should have this because these are security recommendations. So it's not a checklist that's vague and unactionable in the sense of, did you review your code for vulnerabilities? Or make sure not to have any business logic problems. Because sure, those are nice sentiments, but that's not a checklist. Nobody can respond to that. You can't say, yep, I'm done. But you can say, we have applied a linter, we've applied a scanner, we're doing source composition analysis, those types of things. So this looks pretty good for that reason alone of saying we want some actionable policies, we're going to enforce them, and we're going to provide some automation to do so. What might be I'll say the sad thing from a security perspective is that not everybody is going to be able to get to adopt this easily. They need that help to be able to build that maturity into it.
Yeah. Man, a few ways to go here. Yeah, I one of the problems we have is volunteers in open source communities, and security people are not, as I'm pretty active in CNCF's technical advisory group for security, but I'm aware of these guys. I've never been to a meeting, but I know there's a bunch of good folks doing good work. One of the things I was working on with the security tag was what we called Security Pals. It's a pilot which we're about to wrap up, and then we'll see how we bring it into longer going. But the idea is, as an open source project comes into CNCF, can one of us security people who is familiar with CNCF, how it works, sort of reach out and act like, hey, I'm here as a friend to sort of help get you up to speed? There's two levels that we go through their manual, but basically by the time a project is graduated in CNCF, they've gone through both a code audit as well as sort of an architectural security audit. And some of these things we talked about, do they have the security page? Do they have the CI/CD? Do they have blah, 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 blah? But it's still for us a manual process. So maybe we can leverage this tool too. It's they're useful. It's, I think their policies they got in here are pretty decent. But as you said, it comes down to recognizing that you need to have a tool like this.
Yeah, and I think that's a great way. We're shifting from talking about vulns at the beginning of the segment now to talking about the building, if you will. And I highlighted two presentations from DEF CON. So we're going to try to sprinkle those out over the next couple weeks. One was about one that John dropped some foreshadowing on about best practices for application logs. And another one was about basically what works, what didn't work in merging security and software engineering. In other words, not caring so much about, are we talking about DevOps, DevSecOps, et cetera, but more of the how do we add practical security to a DevOps team. And I think that really ties into how you were describing working with the tag there, John, in the sense of partnering with, whether it is with the QA team, in this presentation was describing, to say, hey, the QA team knows how to bring in tools onto the CI/CD process. What if we added a security tool and worked with them on the spirit of quality and security? The other thing is also just building up something like what a tag does as CNCF projects can mature. Do you have support from engineering leadership or organizational leadership? Do they appreciate that we actually need and want to have security present? So I think those tie in. And the other thing I'm going to say before I throw it over to you, John, is that on the logging presentation, that is also something that's a bit more actionable. It's much better for the security team to say, rather than have some logs, make sure you have some visibility to, this is the type of visibility we're talking about, or this is why you need visibility, because it may be necessary for forensics, may be necessary for making sure that you can tag a request that comes in all the way through the different microservices. It navigates to the end, so you can figure out what this request response pair looks like. And oh, by the way, because we are from security, you might be logging a lot of sensitive data. Either please don't, because it might be one of those JOT tokens or one of those password hashes that shows up that we really don't want to show up into logs. Or if you are and have to log sensitive info for that matter, make sure we have a good design for this application logging pipeline so that we can have restricted access to it. So that was my long-winded filibuster to give you a chance to read through the articles there quickly, John. You're on the spot.
Well, yeah, I've read the logging article already. The second one, you're talking about the AppSec Village article, right?
Yeah.
And I've got a reason why I haven't read it, which is because Magno is also, the guy who authored it is also part of the security tag, so I'm quite familiar with his stuff. Us folks get around. I think he's also co-host on another application security podcast. I'm forgetting the name, but I'll give him a tweet out later. Yeah, so a lot of stuff that he's talking about and you're talking about there, it's a DevSecOps thing. We know it. It's important. What's really interesting, I think the one part you didn't cover on that, and the reason we're trying to do this stuff at a security tag, open source people who are volunteering their time either as part of their company or as a hobby, they're frequently not security experts, right? They know that security needs to be in place, but often they might not even be like actual computer science people. It's some dude who, he wanted to contribute something, or he wanted to fix a bug in a product, or he had a really small idea, and the next thing you know, it's something that 10,000 people are using, which happens pretty easily. But they're not security people. So that's really our focus, is how, as a central technical access group, can we help get those people say, hey, we've got some resources for you. We've got a template for what a security response should look like. Here's the people who should be contacted. So all those type of pieces, if we can get them going like that, and then say, if you have further questions, we're here, and we don't bite, right? So that's sort of the goal for that project, and he's really good at that too. The logging one, as I brought it up with Mr. Mike Rothman earlier, is interesting. Find the right tab. Not that I need to read it. I like the thought process behind the article and what she's doing, but I think what was really interesting to me about it is, as I was questioning other Mike, is really the concept of around how do we educate people about that sooner. And he mentioned unit tests also. Like, these are, unit tests in a college class or something like, oh God, a teacher wanted me to have 75% coverage. How do I get 75% coverage on this, right? It's that type of thing. It's not like, so it'd be interesting to see almost like maybe like a 2-semester or 2-quarter class, where first quarter you have like a capstone project and you build something really interesting. And then in the second quarter, someone goes through and breaks everything left and right, and you're left to try and fix it or have some sort of a CTF type thing with it. That could be really interesting, right? Because I think that would give people experience of what's this like in the real world, right? I think, even like I said to him, I'm serious. I say it a lot, the 3:00 in the morning thing, but that's really, I think, it for a lot of us, is until you've had to troubleshoot some of these beasts under pressure, he mentioned metrics and instrumentation. I was talking about logging specifically, but they're both the same sort of category, and that's super, super valuable to keep in mind. I'm with my new project where we are. I've decided to put our code on serverless, so I'm spending a lot of time in Lambda now. You were mentioning that gaining popularity, and one of the things I'm looking at is like, how do I get metrics out of a function in Lambda? How do I get logging? Where's that logging go? Somewhere where I can easily access it. For those of you who may have used AWS CloudWatch, not always the easiest thing to use. So how do you make those things easy? So again, at 3 o'clock in the morning, you're not trying to stumble through everything and figure out how does this stupid thing work. So it's important stuff.
It is important stuff. And I think that echoes one of the things that stood out to me from Magno's talk was that he did make the point, which I think I agree with quite strongly, of that DevSecOps is not just SAST plus DAST plus SCA. Sort of like to your point of what should we be teaching people, people in college, what should new comp sci graduates know? And they shouldn't just know run a SAS tool, run a DAST tool, and run an SCA, and you've learned security. It's more of the principles of how do you work backwards? How do you debug something that's complex? How do you have some security principles behind your design? How do you get the visibility? Just as you were very saying with all of your serverless functions you're working on. I think that really resonated to me. And I definitely don't have any answers, but I did at least highlight that type of perspective and approach to the problem. As well as I'm going to pull in one other article that was, this is our thinky piece for this episode, that was about programming languages. And in all these conversations, the programming language really hasn't come up as a security decision. And I think for the most part, it rarely is. So I'm not really sure I wanted to spend much time on this article because it's but I did want to at least acknowledge that there are potentially conversations out there. But I fall in the camp that pick a programming language that people know, that has a good tooling ecosystem around it, linters, etc., IDE that can give you the little red squiggles that says this looks like an insecure function, ideally, or just these are some ways of identifying some code smells. And it's more about your architecture, your software architecture. It's more about how you're designing your application that I think is going to be more consequential than the language choice, which before I throw it over to you for your thoughts, John, will add a little asterisk in there. I do understand that, or I will acknowledge that language can help you with certain attack classes, such as memory safety issues in C, C++, but that doesn't mean that just adopting a language means you're magically secure. It just means you've acknowledged that you can address a particular attack class, but all the security comes from, I think, everything else that, John, you were describing, and a lot of what we were talking about with Mike in the last segment, too.
Yeah. For those who want a little bit of cheap entertainment, you mentioned red squiggly lines. I've got an ongoing Twitter battle with an account which represents the premier Ed conference. That's Ed, the original Unix line editor. So we've been going back, bickering with each other. I think this started something about Emacs, and now we're talking about how to do one-liners in Visual Studio. But anyways, back on subject here. Yeah, I think you sort of nailed it when you talked about the tooling aspect. When I'm starting a new project, you said a language that people know. What I'm particularly looking for is a language which is popular and it's easy for me to get developers in from a hiring point. Something that people want to join your company to work on that language, right? So probably not Fortran. This article was interesting. So I didn't click on the links in here. Are they going based off of... Yeah, they're going off the Stack Overflow.
Yeah.
There was like one or two articles which came out over the last week or two, and I saw that where I was going was further down in here. I do read these, I just don't read them that closely. They talk about the data science languages, but at the top of the paper, he's talking about not being, just pick something you want to use. But the data science languages are like the R and I think he was mentioning Python or something else in there.
Python usually.
But Kafka. Well, wait, R and Kafka. Kafka's not a language. Okay, anyways. Maybe there's another Kafka. I think Kafka is a stream processing. But anyways, yeah, there's certain languages which you definitely, if you're going to go down ML, you're going to pick one of a few different things. If you're going to be doing a web app, JavaScript is killing it out there as much as we talk about it every week in a bad way. TypeScript's sort of popular, I know. Not too much C nowadays. There was one or two things which were popping up towards the top in that top 10 list again. I think Python was one of them. But yeah, so it's, I think, within realm of you're okay sort of picking a language, whatever sort of makes you happy. If you're in certain fields, you're going to be picking some languages over another. But I think the TLDR on this is don't go, and he did mention at the top, what is it, Flutter? I'm pretty sure he mentioned that in here somewhere, which is a language that came out of Google for doing UI, and I only know about this because I had to look it up last week when I'm like, what the hell is Flutter? So I would probably try to stay away from some of that type of thing, right? Unless you're just doing something as a hobby project. Hell, pick whatever you want. I mean, I think I mentioned at my last place at Accurix, we had a dude in India who was writing a language for the hell of it, just so you could write a language that was more security focused. Sort of blew my mind that someone would do that, and he had done it. So if you want to do that as a project, hey, cool, more power to you. But at the same time, if you're looking to write something where you're going to at some point want to bring other people into it, be a little more conservative in some of your selections.
No, I agree. And I think the other final thing I'll add too is that we've mentioned this in the last couple episodes as well. You're writing code for other people to read. And if you can't communicate verbally, as you're just discussing, in a sprint, here's some design decisions we need to make on this particular architecture, this particular implementation. You're also expressing the same thing through what you're writing. And that is either your documentation for your code, if you have good documentation, or just the code itself, can speak for itself. And I will continue to eternally joke about Perl. And one of the things I'll joke about Perl is that typically only the person who wrote it is the person who can read and understand it. And I think that's sort of why I use that as sort of the poster child, if you will, of languages that aren't as conducive to collaboration. We did have, John, two other articles here that were getting pretty complex, and I think we have to run, and speaking of crawl, walk, run, we have to run to the finish line here to wrap up the segment, but they were covering some injection attacks against DNS and some really cool, what the researchers were calling code poisoning attacks against ML, or natural language models. And to me, I guess my quick overview of these two is that in the DNS case, it was really cool to see very simple payloads, a null byte, or a /dot, or basically escape characters, get shoved into some DNS fields and see how parsers are handling or mishandling them, basically mistaking what the semantic context is, and should they be escaped or not escaped, and are there impedance mismatches in different steps of how these fields are being used. And there was some really neat findings out of it, and it's one of those things I read, it makes me feel jealous, that I'm like, wait, what? All you did was a /dot and you got all that kind of cool stuff, or a /000 and you stuck a null byte successfully and caused some mayhem. That's just really, really cool. And in the code poisoning attack, real quick, to me, it's definitely starting to get into some fancy math, but there the takeaway is what you're building is becoming more complex. So your threat models need to maintain that type of complexity, and you also need some domain expertise. So it's not just a traditional AppSec team, perhaps, who's just familiar with front-end OWASP top 10 types of vulnerabilities. You also need to engage that development team to say, what could go wrong with these models, and how should we prioritize the risks come out of it? So perhaps that wasn't as short of a summary as I intended, but in the spirit of being fair, John, I'll throw it over to you to take us out for our last thoughts on the articles this week.
So the last thoughts on these two, DNS one, guys, go read this. Unless you think you know DNS very, very well, DNS is one of those things which it's the underpinnings of vast majority of stuff we're doing. It's actually a fairly complex protocol. There's a reason people like me say the last thing I want to do is run a public DNS server. And this paper is sort of giving you some of the reasons why, right? How complex is a resolver? What's going on behind it? The slides are pretty decent. On the second one, man, I was still trying to wrap my head around this. I was reading this over the weekend. Yeah. And I think really that the brief, what it comes down to, I don't like the wording they're using. Code poisoning is being used in a different method, because it sounds like it would be, oh God, the guys are talking about supply chain issues again. And this sort of is, but it's not in code. They're looking at ways of actually manipulating without having the source code, without having the training set for a machine learning algorithm. How can they put stuff out in a publicish domain that's going to poison the learning and the results of the tool from that point of view? So it's an area where we're going to see a ton of stuff over the next few years, right? Because this is really rich as we have more and more stuff that's going towards using ML or, machine learning. I forgot my rainbow hands in some way, shape, or form. Ways like this is how you're able to manipulate that without even having access to the code in the first place. So it's pretty neat stuff, but a little bit of a head scratcher at the same time.
Neat stuff, but a little bit of a head scratcher. That's going to be a great motto for us, I think, on ASW. I love it, John. Thank you. As we close, call back to the opening segment, the opening lines, reference to Garbage. I encourage everyone to go out there, wherever you find music, go grab Garbage's first album at the very least, if not all of them. And while you're on those music sites, if you just happen to also get your podcasts from those saved sites, give us a 5-star review, like and subscribe, and just come say hi. We'd love to hear from you. I want to thank John once again. Thank all of you for joining us, especially over in Discord. We'll see you again next week on Application Security Weekly.